So the second part of this is finding the inverse Laplace transform, and you kind of just work backwards through the same sort of process. So we are saying given big F of S is the Laplace transform of little f, find little f of t. Again, we're going to assume that a, b, l, and n are just constants. Okay, so we're going to start with something like this. If we have 0.2 s plus 1.8 all over s squared plus 3.24. We are looking for the inverse Laplace transform of that. So the first thing that we're going to want to do, there's a couple things we're going to want to do. One is since I have an s squared here, I'm going to try to see if this is a perfect square of something. When I do that, I do find that it is 1.8 squared, which is nice because we have that 1.8 right here too. So I'm going to do two steps in one. I'm going to break the numerator up into two separate fractions, and then I'm going to rewrite the 3.24 as 1.8 squared. So we're going to end up having 0.2s over s squared plus 1.8 squared plus 1.8 over s squared plus 1.8 squared. And again, we're going to look at our table, and so now we're going to look backwards and say, okay, I have an s up here, but I have this extra 0.2, so I'm actually going to pull that out. So this is going to come and be 0.2 times the inverse Laplace transform of s over s squared plus 1.8 squared. And then this, since these two match, I don't need to factor out this numerator. I can just leave that exactly as it is. Oops, not equals. And I can say that the inverse Laplace transform of 1.8 over s squared plus 1.8 squared. And then I can just find the inverse transforms of each of these from the table. So I know that s over s squared plus something squared is the cosine. So I'm going to say this is 0.2 cosine of that thing. Whoops, oh my gosh. 1.8t. And then I know that when I have the same numbers here, that's a sine. So this is going to be the sine of 1.8t. And that's how you find the inverse Laplace transform.